Welcome to your first lesson for Algebra 2. We're going to start Chapter 1. This is going to be mainly a review over some Algebra 1 concepts throughout the entire chapters. So if you struggled with anything in Algebra 1, here's a good time to relearn some of those basic skills and get better at them. In Section 1.1, we're going to start with solving linear equations. And I would like to go over some learning objectives before we get into those. One of the things that you're going to have to do here is we're going to write algebraic expressions from verbal expressions. So I will give you a sentence. You will need to turn that into an algebraic sentence. Then we're going to turn that back around. I will give you an equation or an expression. I will want you to write out a sentence that represents it. We will also solve one-step equations. We're going to solve multi-step equations. Lastly, we're going to solve equations for a specified variable. So getting into writing algebraic expressions, we need to be able to look at the sentence that's given and find particular terms, particular words that would tell you what operation to use or what type of variable that we're going to use. So if we're going to find something for addition, you will see terms such as more than, sum, plus, increased by, added to. If you see a phrase that says less than, subtracted from, difference, decreased by, minus, we're referring to subtraction. Multiplication would use words such as product, of, multiplied by, times. Division would use things such as quotient of, or divided by. Exponents would refer to either to the power of this number, or you might see words such as square or cube. And finally, if we ever were referring to a variable, most of the times you're going to see the phrase that says a number. So let's go through a verbal expression here. 2 more than 4 times the cube of a number. We've read it. Now what I would encourage you to do is to go back in and read it a couple more times and really understand what it's asking. So like here, the first thing I would see is that I would see the word more than. 2 more than what? Well, it's telling us to go 2 more than 4 times the cube of a number. And then I see that there's more terms in there such as the word times. I also see cube and I see a number in there. So I'm going to break that box down 4 times. So I'm going to use the number 4 times, and then I'm going to go with the variable, and I'm going to pick a random variable, and the most common variable that we use in algebra is x. And cube is referring to the third power. So I've got that whole box, 4 times the cube of a number, written algebraically. But what about that part at the beginning? It says 2 more than. Well, more than was referring to, if you go back in and look later at the terms, more than was referring to addition. So I want to go to more than that. So that's why I'm putting it second. So I've taken this sentence here and I've written a verbal or a algebraic expression to represent the sentence. Let's try another one. The quotient of 5 less than a number and 12. One of the first words that you should notice is the word quotient. Quotient is a word that's referring to a fraction or division. So when I see the word quotient, I want to look the rest of the sentence for the word and, because what comes before the word and is going to be your numerator, or in other words, the top of the fraction, and what comes after the word and is going to be the denominator, or the bottom of the fraction. So if I look at the word and I see what is actually before it, I have a statement that says 5 less than a number n. So I need to come up with an algebraic expression that just represents that box right there. 5 less than a number. When you see the words less than, you're thinking subtraction. Most people would say 5 minus a number or a variable. But the problem is, if I said I have 5 less dollars than you, I would not say 5 minus whatever you have, because then I go negative. What I need to do is go backwards with that. Take whatever you have, the quote-unquote number, and go 5 less than that. So I will have to go subtraction second. with the 5. My number, my variable, n minus 5. There's my numerator. Now I'm going to go to the word after, or whatever comes after the word and. In this case, it's just the number 12. That is going to be my denominator, so I have to put that on bottom. And I've also drawn the fraction bar that goes underneath everything. I don't just put a fraction bar underneath the variable, and I'm not just going to put the fraction bar underneath the negative 5. So there is a algebraic expression for the sentence that says the quotient of 5 less than a number and 12. Now, these aren't the only words that you're going to look for and. Other words that you would want to look for the word and are words such as difference and sum. Those two particular words are going to include parentheses with that sum or difference. So what I'd like you to do now is go ahead and pause your screen, read these examples, and see if you can come up with algebraic expressions for the verbal ones. All right, let's see how you did. First, did you notice that it said 3 times, so that we were going to do the number 3 times something? What are we multiplying by 3? It says here that we're multiplying by a difference. And if you think back to the previous slide that I had, difference meant that we were going to use parentheses. What are we taking the difference of? That's another one that we want to look for the word and. It says that we're taking the difference of a number and 8. So that's what's going to go in my parentheses. A number and the 8. Difference means subtraction. So we'll make up a variable for that number, which is x minus 8. And there is my expression. Keep in mind that if you didn't have that parenthesis there, you were telling me that you're only multiplying the x by 3 and not both the x and the 8. So there's the answer for that one. The next one, we have the cube of a number. So cube means that we're going to be using exponents, and of a number means a variable. So we will have a variable to the third power to start with. Then it says that we're going to increase it by something. What are we increasing it by? It says 4 times the same number. So whatever variable you used at the start for the cube is the same variable that you're going to use to finish out the rest of this expression. So 4 times that variable. So x cubed plus 4x is what you're going to get for the expression there. So compare your work there and see how you did. Moving on, algebraic expressions to verbal sentences. So we're going to go backwards here. The simplest way is to just write it out the way that you would read it to yourself. For example, here's an equation. If I'm going to read it out loud and I read it to myself, I would say 2 times c is equal to c to the second power minus 4. That's exactly how I'd write it out. That's the most simple way to do it. Most people would probably say 2c, but we're also explaining what operations are we using. So anytime that there's a multiplication, make sure that you're telling me it's 2 times or 2 multiplied or something that represents multiplication. Here we have another one that would say g minus 5, or a variable g minus 5 equal to negative 2. That's the most basic, but we would want to try to think of a second one to go with that. Just to try to be fancy. We have 5 less than a number, and the reason why I'm using 5 less than first is because we had an example earlier that referred to less than. So this could also be described as 5 less than a number g is negative 2. Now moving on to our next objective here is solving equations. The big key with solving equations is that we want to use the opposite operations to get the variable by itself. So if I look at my first example here, n minus 3.24, we want to get the n by itself. The opposite of subtracting 3.24 is to add the 3.24 to both sides. Do that, We're going to get n equals 45.25, and these are our one-step equations. Hopefully these are pretty simple. The one step that is kind of tricky is the ones that deal with fractions, and you may not remember the term, but we refer to it as multiplying by the reciprocal. That was the easiest way that we can get rid of a fraction in front of the variable. So if my fraction is negative 5 over 8, the reciprocal, meaning flip the fraction, so I'm going to trade spots with the top and the bottom, I can multiply both sides by negative 8 over 5 to get the answer. On the left side, those will cancel out the fractions and leave us with the x. On the right side, I can use the calculator and do 20 times negative 8 over 5, and I'll get x equals negative 32. Multi-step equations. There's some steps I'd like to bring up here. First, usually what we got to do with multi-step equations is if there's any grouping symbols, so I'm talking about brackets or parentheses, we need to get rid of them. Use the distributive property to get rid of them. And what ends up happening is that you're going to have a bunch of terms there. We need to combine those like terms on the left side and do them separately on the right side. Step 3, we will have to get all the variables to one side of the equal sign, whether it's the left side or the right side, doesn't matter. And 4, finally solve for the variable. So here's an example. 5 times the sum of x plus 3 plus 2 times the difference between 1 and x is equal to 14. So I've got grouping symbols there. I need to use the distributive property to get rid of those grouping symbols. So there's 4 distributive properties that I have to do. After doing that, you're going to end up with 5x plus 15 plus 2 minus 2x equal to 14. On the left side, there are multiple like terms. It's like a rough draft of a paper that you're doing. We have a rough draft here. We need to edit this thing. We need to make it nice. We need to clean it up. So if my x's, it says I've got a 5x, but I've also got a negative 2x. And then for my constants, my 15 and the 2, those are like. So we're going to combine those together. 5x, take away 2x, will give us 3x. The 15 and the 2 is going to give us 17. It looks a little nicer, and it's going to make it a little easier to solve. Isolate the variable by subtracting 17 from both sides. Now we have 3x equal to negative 3. And finally, we can divide by 3 to both sides to get our solution, so x will equal to negative 1. The last thing that we're going to talk about is solving for a particular variable. This is the hardest thing that we will have to do as far as any type of solving equations. So I'm going to give you the formula here of the area of a trapezoid. A is equal to 1/2 times the height times the sum of base 1 and base 2. Okay, the formula at the end, you can see that says solve the formula for B2 or B sub 2. One of the first things that you need to do, and it's pretty basic, is just identify what is the particular term that you're trying to solve for. Here, we're wanting to do B2, the one that I have in the box. So anything that I have outside of that box, I got to get rid of it somehow. So the B1, we need to get rid of it. We need to get rid of the 1/2. We also need to get rid of the H. Okay, all of that stuff needs to come over to the A side so we can get this equation set up the way that we want it. So how are we going to do this? The best way that I can explain this is that we have to go work outside in to get rid of the parentheses. If I have a 1/2, this is again referring back to the reciprocal part. The reciprocal of 1/2 is 2 over 1, or 2, and everything there is being, fractions are also division, so the opposite of that would be to multiply. If I multiply both sides by 2, that will get rid of the 1/2 on the right side. And this would be what you would have after simplifying. But we still can't quite get into the parentheses yet. We have to get rid of the H. And think here, the operation that's going on between the H and the parenthesis is multiplication. So the opposite of multiplying would be to divide both sides by H. Left side, you have 2A over H. The right side, there's an H on top and an H on the bottom. They will cancel each other out. So here's what you have left. 2A over h equal to b1 plus b2. Now, we want to get b2 by itself. We've got to get rid of b1. Pretend b1 is just a random number, say 1. If I want to get rid of a 1, I would have to subtract both sides by 1. So here, we're going to subtract away the b1. Once you simplify, we will have 2a over h minus b1 equal to b2. Now we've got b2 all by itself on the equal sign. We're officially done. So there's your formula. If you need to find the second base of a trapezoid, you need to do 2 times the area of it, divided by its height, minus the base on top. So I've got another example here that would like you to pause your screen, see if you can go through the steps, and solve for Q. Okay, so the first thing that you need to do is identify the particular variable that you're trying to solve for. There it's Q, which means the 8, the R, and the -5 need to go away. So let's isolate that -5Q, which means getting rid of a positive 8R would mean to subtract away the 8R. Now the 3 and the minus the 8R are not like terms, and because of that, we are unable to do 3 minus 8 for the number. So if they are not like terms, you will just take what you have vertically, rewrite it out horizontally. So here I've got -5Q equal to 3 minus 8R. And again, just looking on the left side here, if I'm going to solve for Q and I need to get rid of that -5, just like when we've solved regular equations, we would have to divide both sides by -5. Now, the one thing that mathematicians are weird about is they don't like to have negative signs on the bottom of a fraction. So here's what we're going to look at. We're going to start with the top term on the left and the bottom. If you have a positive over a negative, overall the number becomes negative. So this will end up making that -3 on top, and the bottom will be a 5. If I look at -8R and -5 on the bottom, a negative over a negative would turn positive, so that on the top, that would turn into a plus 8R. So for a final answer, you could also have -3 plus 8R over 5, and that is what Q is equal to. Let's try another one. So again, pause your screen, see if you can solve for the variable z. All right, so did you identify where the variable is at? I put a box around the letter z, which means wx and the y need to go away from the left side. So first thing I would like to do is let's get rid of the wx. Even though there's multiple letters there, if it's all together in multiplication, treat it as if it was just a number. Make up a random number. I don't care what number that it could be. 2, 3, 5. It's all the same to me. So if I want to get rid of a wx, I'm going to get rid of it by subtracting away, just like the cancels out. So wx cancels out the wx on the left side. If I look on the right side, they all have different letters, B, C, and WX, which means they are not like terms. So I will take what I have vertically there, and I'm going to rewrite it horizontally. YZ equal to BC minus WX. Again, we want Z all by itself. Ask yourself, what is the operation that's occurring between Y and Z? If they are touching, that is multiplication. So the opposite of multiplying is to divide, so I will divide by what I want to get rid of. In this case, it is the letter Y. On the right side, you have to divide everything by the same letter. So Y's cancel out on the left, and you will have a final answer of Z equals BC minus WX all over Y. And that will complete your lesson for section 1-1.